Okay, so this next video is going to show you an example of why you would need a complex number. So say I had this equation. It should be equal to 0, by the way. So you can change that. So 0 equals x squared plus 3x plus 4. So it's a solved by quadratic formula. So the first thing I'm going to do is say, hey, a is 1, b is 3, and c is 4. And then I'll put that into the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a, and that equals negative 3 plus or minus the square root of 3 squared is 9, and 4 times 1 times 4, that's 16, so minus 16, and 2 times 1 is 2. Okay, so let's just subtract these, and I'll get negative 3 plus or minus the square root of 9 minus 16 is negative 7 all over 2. Now, I can see right here, I've got the square root of a negative number, which means I'm looking at an imaginary number. And I'm going to split this into the real part and the imaginary part, and that'll be a complex number answer. So I've got negative 3 over 2, so that's negative 3 divided by 2, plus or minus. Now, the square root of negative 7, I can just rewrite that as the square root of 7i. Okay, just like I was doing up above. So that would be the square root of 7i divided by 2. And that is the value of x. That's my solution. And x has the solution has two parts. There's the real part, and then there's the imaginary part. I keep having trouble spelling imaginary. Okay, so this is why we have complex numbers, because sometimes when we get a solution to a quadratic, it has an imaginary number part to it. And so together this makes a complex number.